All right, so as you can see, we have linear inequalities, and that's what we're considering today. So an inequality is a statement which compares two expressions which are not equal. So usually the symbols we use in an inequality are less than or greater than. So when it is less than, it is represented by this symbol, and when it is greater than, it is represented by this symbol. So sometimes we can have less than or equal to, in which case you have a stroke right beneath it, or greater than or equal to, you have a stroke right beneath it. So these are the basic symbols that we use in inequalities. So generally, the operations involving inequalities, which is still algebra, is much the same way as we would handle a linear equation that has an equality sign, all right? So that is the general principle. Only that in the case of inequalities, there are just some twists to it, which I will explain as we progress. So let me start with giving you some examples so that you see what it looks like. So let's have this. So we have this example here. Find the values. Find the values for which 4x minus 5 is less than 11. So we are just going to treat this as though this were an equality sign, all right? So we have 4x minus 5 less than 11. So our negative 5 is going to be added to both sides so that it can cancel out the 5 and we'll be left with 4x. So that becomes 4x less than 11 plus 5. And so that gives us 4x less than 16. So we're going to divide both sides by 4, and our answer is x less than 4. It is as simple as that. Now, if you wanted to represent this on a graph, it's very simple. So you have a scale here, and so you have from your this is 0, all right? So let's say this is 0 instead, since we're talking about positive numbers. So from 0, you have 1, 2, 3, 4, 5, and so forth. So how would you represent x less than 4? That means you would start from positive 4, and then you have an open circle because it's simply less than. So that means all the values are less than 4. So you're going to point your arrow towards the left-hand side because it indicates that these are all the values that are less than 4. You have 3, you have 2, you have 1, you have 0, you have -1, -2, and so forth. Now my circle is going to be open and unshaded because it is just less than. But if it was less than or equal to 4, then I would have to shade this circle. But in this case, it's just less than. Now let's take another example. So we have this question: solve the inequality 3 into 12 minus x greater than or less than 4 plus 5x. So we're going to open up this bracket, and that gives us 36 minus 3x greater than or greater than or equal to 4 plus 5x. So we're going to collect like terms now. So our plus 4 is going to come over here, and it becomes -4 greater than or less than. Our -3x goes over to become positive 3x plus 5x. And that becomes 32 greater than or less than 8x. Now, if we divide both sides by 8, we are going to be having our x, all right? So this is going to be 4 greater than or less than x, which means that x is less than, sorry, I keep saying greater than or less than, greater than or equal to, which means that x is greater than or is less than or equal to 4. So that is the answer. Now, how would you represent this on a number line? Very easy. You have your line over here, and you have this to be your 0, 1, 2, 3, 4, 5, and so forth. And that's because it's positive 4, right? And it says x is less than or equal to 4. So that means my arrow is going to be pointing towards all the numbers that are less than 4. And then there's going to be a circle here. And because this is less than or equal to, it means this is going to be shaded, showing that it starts from 4 because it is either equal to 4 or less than 4. So that's going to be shaded. Now, this is the basic way we could solve inequalities. Like I told you, it's just like solving linear equations in algebra. So let's take a more interesting example. So this third example says, given that x is an integer, find the lowest 3 values which satisfy the inequality 3 over 5 into x plus 2 minus 1 over 3 into x plus 3 less than or equal to x plus 5. So we are going to simplify this and find the values of x. But take note, we're going to find the 3 values which satisfy this inequality. Well, we're going to find out about that when we get our answer. Now you can see this is 3 over 5, this is 1 over 3. So one way to make this become whole numbers is to find the LCM of these denominators, and we multiply it across. Remember the principle, whatever you do to the left side, you do it to the right side. So what's the LCM of 5 and 3? That's 15. So we're going to multiply everything here by 15, and we do the same to the right hand side. And if we do that, you'll see that this over here, 5 goes into 15 3 times, and 3 times 3, that gives us 9 into x plus 2 minus 3 goes into 15, that's 5. 5 times 1 gives us 5 into x plus 3 less than or equal to 15 into x plus 5. So that is exactly how it's going to be. So this is the same question. We just simplified it by eliminating these fractions. So now we're going to open up these brackets. So here we have 9x plus 18 minus 5x minus times plus minus 5 times 3, 15, and less than or equal to 15x plus 15 times 5, 75. So let's resolve these first. Here we have 9x minus 5x, and then we have 18 minus 15. And that is going to be giving us 4x. 9x minus 5x is 4x, plus 18 minus 15 is 3. Less than or equal to 15x plus 75. So we're going to take like terms again. And so here we're going to have 4x, positive 15x comes over to become negative 15x, less than or equal to negative 3 plus 75. And so here we have negative 11x less than or equal to, here we have 72. So what are we going to get? Now at this point, I want to pause and let you know a fundamental fact and something you must never forget when solving inequalities, and that is, whenever you have to divide both sides by a negative sign, then the inequality will switch to the opposite. And so in this case, we are dividing both sides by negative 11. And so when you divide both sides by negative 11, your inequality, so this becomes x greater than or equal to 72 over negative 11, or instead negative 72 over 11. Now, if you go ahead to change this to a mixed fraction, you're having x greater than or equal to negative 6 whole number 6 over 11. Now, don't forget the question. It said, given that x is an integer, all right, find the lowest 3 values which satisfy this inequality. So this inequality says that x is greater. So x is greater than or equal to minus 6. Minus 6 whole number 6 over 11. So what are the 3 lowest numbers that, if we put them in place of x, they will be greater than minus 6 whole number 6 over 11? Now remember, these are negative numbers, right? So the very next integer, all right, the very next integer right after minus 6 whole number 6 over 11 is minus 6. It is greater. It is the very next integer that is greater than this one. And the very next integer that is greater than minus 6 is minus 5. Now the very next integer that is greater than minus 5 is minus 4. Remember, we said integers. That's why I don't have any fractions attached to them. So these are the 3 lowest. So this is like low, lower, lowest. All right. I hope you understand that because of the negative signs. So that is the answer to that question.